We're going to start our discussion of the detailed terminal operations with some of the more simple ones, forEach and forEachOrdered, and then we'll get into the more interesting and complicated ones next, which is collect and reduce. So forEach and forEachOrdered are typically used for relatively simple programs. I use them a lot when I'm doing test programs, when I want to print the results out to the console. And again, we're going to show the Hamlet program. This is very simple, so we won't spend a lot of time on it. You can find that particular program here in the EX12 project. So there are two terminal operations that return no values, forEach and forEachOrdered. And we're going to look at a couple variants which appear here in this program, so you can follow along if you're curious about how this stuff works. This program, as usual, is going to take the names of characters from Hamlet, get rid of ones that don't start with uppercase or lowercase h, capitalize them, and sort them. So that's just what the program is doing. And then we're going to have different terminal operations at the end do different kinds of things. In this case, forEach, as you can see, just takes the designated action, which in this case is just taking the print line method reference and applying it to every element in the stream. As a quick side note, forEach takes what's called a consumer. Consumer is a functional interface which has a way to accept things that are being given to it. In this case, by accepting, println is going to print the results out. That's what it means to accept something in the context of the println method. Now, note the example here kind of made this point, but I'll make it even more clear. This has a side effect, and it can do whatever it does, it'll do as a side effect of being called on each element in the stream. So in this case, println printed the element, but you could have other side effects, such as what I'm showing here. So in this particular example, we define a local variable called results, and that's a list of strings, and we make it an array list. And then we're going to pass in the add method reference on the results object. And that will have the side effect of adding each element that made it through this stream to that results list. I do not recommend you do this for several reasons. The most obvious one is you have to remember to initialize this local variable, and it's all too easy to forget to do that. And when people do it like this, I've looked at a lot of student code over the years where people forgot to do that, and their code gets a null pointer exception, and they're rather mystified as to why it was happening. This is just a bad idea. So this is a bad idea for a couple reasons. That's one of the reasons. It's another bad idea if you start trying to make your stream a parallel stream. Because if you do that, if you make your stream a parallel stream, you may forget that the array list class is not thread safe, which means if add is called from different threads at the same time on the same object, in this case the results object, chaos and insanity will ensue, and you'll have race conditions. So yet another reason not to do this particular approach, because you may not only may you forget to assign it, but you may also forget that when you start optimizing it that it doesn't have the behavior that you expect. Now, one way you could solve that particular problem here, if you were so inclined, if you were masochistic and wanted to hurt yourself, you could make this results local variable be a concurrent structure, concurrent collection that would be able to be added to by multiple threads at the same time. But this is still a bad idea for the reasons we talked about before. It's error prone because you could forget to initialize this, number one. And number two, it's just not the most efficient way to do things. There's much, much better ways. Another problem with this is you're going to have a single point of contention because all the threads in the stream are going to be trying to add things to that single results queue object. So just a bad idea. Now, there's another method called forEachOrdered. And forEachOrdered is very much like forEach, the difference being that it makes sure that the order is preserved in the order in which the items were encountered. This is what's called encounter order. And we'll talk more about encounter order later when we talk about things like splitterators and so on. But basically, encounter order is just the order in which the items are seen by the stream. Sort of think of it from left to right. And forEachOrdered will actually preserve ordering even when we have a parallel stream. In contrast, as we'll see, if you don't have a parallel stream, this doesn't really matter for the most part, but if you have a parallel stream and you use forEach, then the results that are being presented may not preserve encounter order, but if you do use forEachOrdered, it will preserve the encounter order. So this really only matters for parallel streams. And once again, like I suppose if you were really sick and twisted, you could go back and you could use the concurrent linked queue thing. I'm sorry, you could get rid of the concurrent linked queue, and you could use the array list implementation with forEachOrdered, and you would sort of get things that work, but it's a bad idea. So the most important thing to come away with from this discussion is there are these methods that are terminal operations called forEach and forEachOrdered. You probably don't want to use them for anything other than debugging, because there are almost always better ways to use better terminal operations.